you missed it. I'm joined today by Shoshana Dodge, the Education and Outreach Program Administrator for the office, who's going to be helping moderate the chat. So you might see her posting stuff. So at the Office of Sustainability, we serve as a resource advocate and catalyst for sustainability at Tufts, often serving as the bridge between ideas and their practical implementation. So we work on planning, reporting, communicating, and facilitating sustainability at all campuses. So today, I would also like to thank the student group Tufts Climate Action for co-hosting this webinar. Since 2012, TCA has been pushing Tufts to do more sooner to reduce its carbon emissions. They have weekly meetings, and Julia or Helen will put info about them in the chat. Anyone's interested in joining them. So the Path to Carbon Neutrality at Tufts webinar series will spotlight the various initiatives at Tufts that contribute to Tufts reaching its goal of carbon neutrality by 2050. So we're still planning them out for the next year, but keep your eye out for that. Today, Ruth Bennett, the Director of Strategic Capital Programs at Tufts, will discuss how the Operations Department is leveraging existing projects and implementing new ones to reduce carbon emissions from our buildings and infrastructure. Ruthie is a lead accredited architect with over 20 years of experience in project management, community engagement, and real estate development. I first met Ruthie maybe like 15 years ago when she was considering pivoting to work more in the sustainability arena. Since then, she's worked for the Boston Architectural College, teaching a master's level course on renovating existing buildings using sustainable principles and renewable energy sources. She's been the energy manager for Arlington and Bedford, and she joined Tufts 4 years ago as the Director of Strategic Capital Programs. Since arriving, she has been a tremendous ally for our office and a leader in moving Tufts towards a more sustainable way of building, renovating, and managing our physical infrastructure. So today she's going to talk about the work done with not one, but two consultants building on each other over the past 4 years to figure out one of the most challenging issues that we have when looking at decarbonizing Tufts operations, which is how do we decarbonize our buildings and utilities?
Right.
So over to you, Ruth.
Great. Thank you, Tina. Actually, I met you, I don't know how many years ago, and I was looking for a job. So here we are all those years later at Tufts, which is a really great place to be in terms of, what I do, because Tufts is really committed, totally supportive to being carbon neutral by 2050 or before. And everything we're doing in operations and capital programs and utilities is really supported by the university. They definitely look at me to say, can you get going faster? So I feel, lucky to be here. So what I'm going to talk about is we worked with two consultants, and there's many more that are on the sidelines helping us about how to be carbon neutral in our buildings and our utilities, right? All of our electricity, the water, hot water, cold water, heating, cooling, lights, water consumption, all of that is what I work on. So in the buildings and below ground. And I'm happy to take questions at the end, or if Tina thinks there's an important question in the middle, she'll send it. So I'm doing a presentation. I'm also really happy to dialogue. So just the agenda, we'll talk about sort of where we are now, what's our current situation, what are the ongoing initiatives, how are we going to define carbon neutrality for our buildings and our campus, and what are the strategies that we're using to get there. So just a reminder, Tufts is a signatory to the Climate Leadership Commitment, and currently we do rely on fossil fuels. Basically, the gas and oil industry are so heavily subsidized that almost every single building naturally relies on gas to heat it, to get electricity, to cool it. And so our goal is to try to get off of fossil fuels, knowing that renewable energy is a lot younger as an industry than fossil fuel and not as heavily subsidized. And so our commitment is to use renewable energy anyways, even if it's not as subsidized, and also to lower how much energy we need in the first place. We also really want to enhance the resilience of the campus. I don't have to tell all of you, there's like heat and rainstorms and all this kind of stuff coming at us. And we need to be able to be resilient for whatever weather, event, disaster comes our way. And since most of our utilities are underground, we need to be able to get these utilities to our buildings, if not one way, 2 or 3 different ways. We can't have a break in a steam pipe and then the whole campus has no heat. So a lot of what we do is make sure that we have redundancy so that we can be resilient. And preparing for the future, right? What is the future of basically an urban campus? We can't put enough solar panels on our roofs to renewable energy our way out of it. It's just, our buildings are too big, our consumption is too high, and our roofs are too small, relatively speaking. And so we need a sustainable strategic plan for carbon neutrality. We have some money, but we don't have, tons of money. And so how do we do this in an intelligent way? And how do we do it in a way that the campus keeps operating, right? If I said this 2 years ago, now I sort of get afraid of saying it, but if I could have nobody on campus for a year, I could dig it all up and put in new pipes. But, that almost happened. But that doesn't happen. We have to operate. Buildings have to function. Students are walking on campus. They're living on campus. Faculty are coming to campus. How do we do all this change while still operating, a large, complex and complicated campus? So what we did in the very sort of nature of Tufts is when we started this process, we talked to a number of stakeholders, and we're looking at sort of a quadruple bottom line. It used to be the triple bottom line, now it's a quadruple bottom line. So clearly we want to be sustainable. We want to conserve our energy, and we want to lower how much energy each building utilizes. So that's on the top right. And then we also have a capital planning program. There's a number of folks in operations who actually renovate buildings, build buildings. And how do we, and there's a plan, right? There's a 10-year plan of which buildings are going to get funded and renovated and new ones built. And how do we use the money that's already been allocated to these projects to increase sustainability? And a lot of what we do, and there's folks here I see on the webinar from procurement, how do we make sure that when we hire an architect, when we hire a consultant, when we interview a contractor, that they understand our guidelines, they understand our energy use intensity target, they understand that we want renewable energy, we want recycled materials. How do we put that in our policies and our guidelines so anybody who comes in the door understands what we're looking for? If we ask them to create a plan that's based on an energy consumption of a building, they need to be responsible to that plan. They can't just hand it to us, build a building or renovate a building, and then good luck, Tufts. They have to be part of our team. And that's a bit of a change from before. It used to be, you hired a contractor because they did the best in that arena. They built, they managed wood frames or they built new buildings. But we're adding on to that the responsibility to be sustainable with us. Financial, I talked about procurement, also financial, right? We need to mitigate our risk. We need to mitigate our risk in terms of weather events, right, and disaster, and also making sure that whoever we hire has the experience. So some of the things we're doing are a little bit new, and we can't hire someone who hasn't done it before. Maybe they've only done it one time before. So that's a risk in terms of, being closer to the cutting edge. So we always want to make sure we're mitigating our risk in terms of who we hire. And, really each dollar is so valuable and so precious that we want to make sure we're using it well. And then, of course, we are an academic institution. So one of the goals that we always have is how can we improve the environment for teaching, for learning? How can our campus itself be a living lab so students can be here and see how sustainability is done? And we want to be a leader. I think Tufts has been a leader, and we're moving back into that position by things that we're doing on the operations side. So we always want to maintain that leadership role. Oops. Just to give you a quick history, so we actually have been reducing our energy from buildings and our fleet, all of our vehicles. And this reduction over time is actually even more impressive than it looks because we've built the science and engineering complex. We took 574 from kind of like a warehouse building to a fully operated academic building. So we've added energy consumption in buildings, and we've still been lowering our energy consumption. We've eliminated fuel oil, so now we only use gas, which I know doesn't sound great, but gas is better than fuel oil in terms of emissions. We do track our emissions. Tina's office does a tremendous job of tracking where our emissions are coming from. I'll show you a slide at the end about how we can visualize it. We built a central energy plant. I won't go into that because you could have like a 2-hour webinar just on that plant. But basically that plant takes natural gas and it uses it, each therm of natural gas, it uses it 3 times. So it uses it to make steam to heat our buildings. It uses that therm to make electricity. And then we use waste heat again as a source of energy. So the central energy plant, which you could see on Boston Ave, It's a really efficient engine for creating energy. But yes, it uses gas, and part of what we're looking at over time as the industry gets more robust is how do you take a big engine like that and get it off of gas? Can you put it on an alternative fuel? How big is that industry? How secure is alternative fuel? So we know that's something we need to think about as we get further into our plan. We are buying electricity, renewable electricity. This is, again, another sort of complicated conversation, and Tina, you can have another webinar on that one, but we are putting money into more renewable energy. Even if it's not on our campus, we're putting money to create that renewable energy that some customer is using. We have a whole bunch of solar panels on our roofs. We have one in one of the buildings in Coho, 12 Bellevue. We have it on a number of dorms. We have it on the Dowling Hall. We're putting it on the new Cummings building. Again, we can't sort of solar array our way out of all of our energy consumption, but we are putting in as many solar panels as we can on as many roofs as work for us. And then we're managing our growth and our renovations. Every time we do a renovation, we make sure that we're lowering the energy consumption of that building, even if it's, even if we're adding to the building or it's a new building. So we're always conscious of that. Quick sort of summary of our campuses. We have 4 campuses, as you know, and so you can see Medford in the blue is kind of the biggest consumer or the biggest emitter, and part of that is because we have this central energy plant. Part of that is that's our biggest campus with our most square feet. And so what I'm working on is each of the campuses individually, Medford, Grafton, and Boston. I'm not working on scope 3. That's probably more of Tina's office. I'm working on literally the buildings, how much energy they consume, and how much carbon we emit from creating the energy to heat and cool and run our buildings. We do have a plan for Grafton that we're working on. Boston is a little more complicated because the city of Boston has its own rules, and we have a lot of very dense buildings. They're much taller than the ones on Medford, so we're working on a plan there, but it's different than what you'll see for the Medford one. Here we go. So what was our plan? We hired one company in the beginning called Ramble Engineering. They're out of Denmark, and they helped us collect all of our energy data. We have millions and millions of square feet, and we have tons of utility bills, and so they helped us kind of get our data into one coherent place and analyze it. But then we hired Ecosystem, and that is a company that actually, not only do they do carbon neutrality plans, they're an engineering company, they implement the plan. So if we say to them, okay, we want to have this, we want to have hot water from this type of engine going to that building, they literally design it and do the construction. So they're a real hands-on company. And we did a lot of outreach, Office of Sustainability, Operations, Finance, Purchasing. We talked to academics as well to get everybody's thoughts, opinions, and knowledge about how to go carbon neutral in our buildings and our utilities. We also looked at, not only do we have a plan for buildings, but we have a plan for deferred maintenance, meaning you have to fix your roof, you have to upkeep all of your heating and cooling equipment. Things break down, things get to end of life, things are overused, so we need to dial them back. So there's an analysis of each building and how much maintenance it needs. And if we need to replace something, can we replace it not in kind, but with the future carbon neutral concept in mind? And I'll explain more about that, but that's a really key change that we've made. It used to be we would replace in kind, it was a good thing, now we got the newer version, but it was the same concept. Now we're saying, we're changing, we're having a new future. How do we replace each piece of equipment as we go with that new concept of how we're going to be carbon neutral? And another thing we've brought in is a life cycle cost analysis. So for example, if you're building a house and you want to put siding, you could put plastic siding, which is bad for the environment, but extremely cheap, right? And it lasts 10 years, maybe. But if you bought cedar siding, which is very expensive and looks incredibly beautiful and costs more money, but it'll last you longer. And if you maintain that cedar siding, you could get 30, 40 years out of it. So we're looking at not just the first cost, the cheapest thing to buy, but actually what's gonna last the longest, what will lower our maintenance cost, what's part of our carbon neutral future, and we're using that to analyze with a spreadsheet what are the different costs of all the different options. So really trying to change how operations and facilities does our analysis. So what is carbon neutrality? There are, tons and tons. There's a lot of universities, defining carbon neutrality. But for us, what's really important is, like I've said, we're on an urban campus. So for us, carbon neutrality is either decarbonizing so we don't emit carbon, or offsetting the carbon that we do emit. So our goal is to decarbonize our campus by 80%. So 80% of our emissions we will not emit anymore. That's a big, big goal. But 20% we won't be able to change. You know, we at this point you can't get off gasoline as your energy source. So how do we create renewable energy somewhere else that's equal to how much carbon we're emitting? And it's an 80-20, which is kind of what happens to urban campuses. There's only so much we could do. Our goal is to be 100%, but we're also being realistic about, again, sort of, you know, we're on a hill, we're in an urban environment. There is no real alternative yet for a big central energy plant in terms of its gas. So we're being realistic about what we can do while we're still trying to achieve, you know, the highest we can achieve. So this is our plan. We started in 2020, and by 2050, you could see the blue line, that's the emissions. We're going to go down to zero. Again, remember that 20% of that zero is creating renewable energy somewhere else, equal to how much energy, how much carbon we emit. But the top line, the orange line, is energy use intensity. So how much carbon do each of our buildings emit because of how much energy they use, right? So if you put in a window air conditioner in your dorm room or your classroom, you're using energy, right? Each of those uses energy. If we had chilled water from a central energy plant, which is really efficient, then that building would get air conditioning, but it would use less energy to create the same level of air conditioning. If you insulate your walls, right? So if you have a heating system that's really great, but your walls are paper thin and your windows are single pane and all the heat's going right out the window, then your building's using a ton of energy to get to the same place of heating. But if you insulate your building, if you put in double pane or triple pane windows, you're maintaining more heat inside your building. So you're lowering how much energy the building needs to maintain thermal comfort. So the orange line goes down by 50%. Can't go down by 100%, right? Because you need to use energy to heat and cool. But as the orange line goes down, the whole campus itself needs less energy to hit the same level of thermal comfort. So, and this is sort of an overlay of how we're going to transition away from, as you could see, natural gas, right? Natural gas is in the orange. That's most of what we use now to heat and cool. We have a little bit of electricity. So what we're trying to do is increase our renewable electricity, right? And we're also increasing renewable fuel. So you can see the green bar on top gets higher and higher. It's only so much it could increase. Again, at this point, that industry is a little bit new. I used to live in California, and when you drove over the Bay Bridge, it smelled like French fries because all of the food waste was being turned into energy. And it smelled, you know, fried foods were great for that, and it smelled like French fries. But we don't have that here yet. We don't have a system that's robust enough to deliver alternative fuel to our campus, right? I mean, there are pipes in the ground now that are delivering natural gas. It's all set up. It's subsidized, already done. We have to have that same concept of the delivery of the fuel. And we're competing with a system that's, you know, 100 years old, maybe more, maybe older, and already in place, already in the ground. So if we have a gas, you know, a pipe that has natural gas in it, and we want to take that pipe out and put in a pipe for alternative fuels, think about how complicated that is, because where's my alternative fuel coming from, right? Where's that pipe? Is it in the road? Well, the road already has natural gas pipes. So how am I going to compete with that? Or even into our building? I'd have to put in the new pipe, then take out the old pipe and, you know, dig up our campus. So it's challenging. In utilities are underground and everybody forgets about them, but there's tons of pipes and they overlap each other, and taking out one, you know, can sort of open up a whole rat's nest. So that's part of our challenge, is physically how do we do it. And as you can see, the orange bar gets smaller and smaller. That's the energy use intensity going down. As we build, you know, as we insulate our buildings, as we put in smarter pieces of equipment, the amount of energy goes down. So even at the end, we'll still be using energy, and we'll still be using some natural gas, but it'll be a lot less because of the changes we're making to our buildings. Insulation, windows, roof insulation, that kind of thing. So,
Ruthie,
yes,
before
please.
we move on, there was a question on that last slide. Why is the biggest change happening 2045 to 2050?
Oh, okay, that's our central energy plant. Right, so again, our central energy plant is a very efficient plant, but it's on natural gas because that's really the only reliable fuel that we can get right now for such a big piece of equipment. And so what we're saying is we know that central energy plant will have to get off natural gas at some point, but we don't know what the answer is to that. So we're assuming sometime between now and 2045 to 2050, a technology will emerge that is accessible and available and affordable. But we don't know, like I said, we don't know what that is yet. So instead of saying it'll never happen, we're saying it will happen, right? People are working on alternative fuels. There are biofuels out there. They're just not available yet for us at the level that we need. So does that answer the question, Tina? You kidding me?
Rebecca, I feel like that answered the question.
Yeah. Okay, great. Excellent. Love the questions. Okay, so this is the energy flow diagram for our campus, right? And you'll see that here's the electricity from the grid. And we are really lucky where we live because the utility companies are required to increase the amount of renewable energy they use to provide us with electricity and for our heating and cooling. So without us doing anything, the grid, right, the grid that delivers electricity to us or delivers energy to us has to get greener, right? And if you live in Massachusetts and you pay your utility bills a little bit a piece, a little, a couple cents every month, that basically goes into this pot of money and it forces them, the utilities, to create more renewable energy. So without us doing anything, the electricity we get from the grid will get greener. We'll have less emissions over time. And what we're doing now is all this black right here, this is us using gas, natural gas, and fuel oil, not too much of that, but a little bit, to create our energy. So first of all, you see there's a lot less renewable energy right now from the grid, and there's a lot of us creating energy with our central energy plant. But the biggest thing that happens is as you go to this, so this is the input, this is the oil and the renewable, then the electricity coming from the grid coming in, and this is the output. And all this gray is loss. This is just wasted. We can't do anything with this. So no matter how efficient we are, we're wasting all of this 189,000 MMBTUs, millions of BTUs. And that's part of what we're going to do to change our efficiency. We're going to use more efficient equipment so that on the other side, after we've used the oil and the gas to create electricity, to create hot water, to create cooling, we waste less. And the reason why I'm going over that is because the biggest thing we can do to lower our carbon emission is become more efficient. If our buildings used less energy to heat and cool and turn on the lights, that'll have the biggest impact on us. And it's also not very expensive compared to like putting in new infrastructure. So this is a really important slide because if you look at the next slide, the goal of where we want to be in 2050 is here's the grid, right? Here's the power lines that come from Eversource and National Grid. It's a bigger amount of our electricity and it's clean. By 2050, they have to be, I think they're at 80%, if not 100% renewable energy. So this is really good for us. No matter what we do, we'll have cleaner electricity. But also, we're using more efficient and more lower carbon emitting systems, like an air source heat pump, or alternative fuels that emit less carbon, right? No matter how much of it we use, they still emit less carbon than our central energy plant, which was using natural gas. So if you go back, I feel like I'm not explaining this well, but if you go back, you can see we're getting electricity from the grid and it's somewhat clean. And you'll see the next slide, right? It gets more and it's cleaner. We don't have to do anything, it's free. And the central energy plant, we're creating a lot of our heating and cooling and electricity from a central energy plant, but we're using gas. And then we're wasting all of this gray on the other side. By 2050, right, more from the grid, it's cleaner. We have air source heat pumps, which I'll talk about later, but those are cleaner equipment to produce heating and cooling. Just a little bit of natural gas, because we have wood frames and they probably won't get off natural gas for quite a long time. And we have an alternative fuel, which again, we sort of have a guess at what that's going to be. We don't 100% know what it's going to be. But the biggest thing is if you go over to this side, the gray, the waste is a third of what it was before. So we're more efficient. Even if we're still using natural gas, we're more efficient. We waste less. And part of what you see here, this is the cooling load and the heating load. So it's we need less heating and less cooling than we needed in 2020 because we're more efficient. So again, our concept really is about changing how much energy we need and then using more efficient equipment to give us that heating and cooling. So using less energy, whether it emits carbon or not, using less energy to run our campus. So we have a couple of strategies for carbon neutrality. I think I've said this about a bazillion times, but the number one thing is to reduce wasted energy. So that way all of our equipment is sized for lower consumption. The big thing on our campus is we have sort of three areas. We have the upper hill with the central energy plant. We have kind of lower hill where Tilton is. And then we have the athletic district across Boston Ave, College Ave, which is sort of a three districts. And if you have one engine and it feeds 4, 5, 6, 10 buildings, that's often more efficient than each building has its own boiler and its own chiller. So what we're trying to do is create little hubs, not little, the central energy plant is a big one, but trying to create different parts of the campus that have central distribution. So for example, I could build one piece of equipment that has 100,000 BTUs, so 100,000 units of energy, and you could send it out to 10 buildings, right? And all of my energy is consumed. If I have 10 buildings and each of them has its own engine, then they have to make sure that they have more than, I didn't explain it well, but each building having its own boiler, that boiler has to be oversized for that building because there's nowhere else to borrow if that boiler doesn't have enough, right? So if you're in Wren Hall and you have your boiler and you need 100 units of energy, and all of a sudden that boiler goes down or it's not working well, you have nowhere else to look for energy. It's just you have one boiler. But if you're on a central system, then I could say, okay, I'm going to borrow 5 units of energy from the other building next door because you're all connected. It's more efficient to push out energy to 10 buildings than each building have its own. So that's part of what the central system does. It's also less maintenance for us. We have one engine, we manage that one, and we have pipes from that engine to other buildings, as opposed to 10 boilers, each one needing its own maintenance, each one could break, each one having its own service contract. So the other thing we have is that we are a legacy campus. We're an extremely old campus, and we have mostly steam heat, right? What's great about steam heat is you make steam and you put it in your radiator and you're hot. It's great. It works, no question. The problem with it is to get the steam, you have to heat the water to 212 degrees. And if it's 50 degrees outside and you need a little bit of heat, you still have to heat all the way up to 212 degrees. You can't be like, I just need a little bit of heat. You have to do the full heating. All of the energy to get from water to gas, you need every time you want heat. If you use hot water, if it's 50 degrees outside, you need a little bit of heat, you can get 120 degree water, you put it in your baseboards around your room and you're warm. If it's freezing outside, you heat the water to 180 degrees and you put it in your baseboard around your room and you're hot. But you can modulate how hot that water has to be. The lower the temperature of the water, the less energy it takes to heat it, right? 120 degrees takes less energy to make than 180 degrees. So we want to get off of steam and go to hot water. And this is a typical response to a lot of universities and institutions in the Northeast, old steam legacy campuses. They want to get off of steam to hot water. Part of what we do is some buildings have what's called a steam to hot water exchanger. So the steam comes in the building, right, because we have these old steam pipes, but in there, this piece of equipment, a heat exchanger, takes the heat from the steam and puts it into the water and heats the water. So we're trying slowly to get off of having steam as our heating source, but it takes time. Another thing we're going to do is electrify with heat pumps. So heat pumps, I don't know if any of you have seen, if you've gone to a hotel or some people have it in their houses, is one piece of equipment that heats and cools, and it uses electricity. And electricity is easier and better on the environment than natural gas, because you could make electricity with renewables, right? You could have wind or solar or geothermal or nuclear, but you can create electricity with renewable energy. You can't create gas at the moment really with renewable energy. So if we start to use heat pumps, which heat and cool using electricity, we start moving to an electric campus. And that's really the direction for carbon neutrality, is to electrify, because it's easy to create electricity with renewable energy. So that's the goal at the end of the day, surprisingly, is to be all electric, as opposed to what we have now, which is even if we went from steam to hot water, right, so hot water is more efficient, it's still being heated by gas. So it's a more efficient use of the gas, but it's still gas. The goal is to finally get all the way to electricity. One thing we're doing now is we're looking at electric boilers, right? So let's say we want to have hot water in our buildings. Now it's on gas. How about if we had a boiler that got the heat of the water when you turned on the switch, when electricity came in and was the energy source to heat the water? So we're looking at all these ways constantly to figure out how to get to carbon neutrality with the building systems that we have, and what do we have to just, scrap and start again. Switching to alternative fuels, like I said, that's the goal. We can probably do it on a small, one boiler at a time, but we're not ready yet to do it on a big scale. The natural decarbonization of the grid, again, lucky for us, we live in a state that is requiring the utilities to get greener. So all the electricity that we're going to get will slowly get greener no matter what we do. And then, as I said before, 20% of our emissions we cannot not have. We're just an urban campus with a lot of buildings, and so we're going to create renewable electricity somewhere else in Massachusetts or somewhere else in the country to offset the amount of carbon that we're still emitting because of our campus. So here's, so I'm halfway. I think I'll try to hurry up so I can have time for questions. Basically, this is a map of our campus now. So this is the central energy plant over here. And all of our buildings, for the most part, are using hot water, either steam or hot water to heat the buildings, and they're connected to the central energy plant. The goal is to have everything connected to a main engine. So like down here, there's Tilton, and that could be a main engine, and over here is the athletic district, that could be a main engine. But right now you see there's a lot of steam coming from the central energy plant and then being turned into hot water when it gets to the other buildings. And so as we go forward in the next, 20 years, or 10 years actually, wow, 10 years, 2030, we're looking at trying to get more of our buildings to be hot water directly from the central energy plant as opposed to steam to hot water. And we're trying to get, all of these buildings around Tilton to be connected so they have distribution from Tilton. Same thing over here, the athletic district, to have its own engine and distribute hot water and cold water over here, as opposed to each building having its own individual boiler or chiller. So we're trying hard to become a central distribution system with 3 different areas of central distribution. And the goal ultimately by 2050 is that everything is on a district. No buildings are standing alone. We're not talking about wood frames. They are too small, and it's another conversation, which we're working on, but it's not the same concept. But everything is connected by district, right? So every building is getting the efficiency of a very large engine producing their hot and cold water as opposed to they individually producing it themselves. I think I'm close to the end. So the other big change that we're doing is and I talked about this a little bit in the beginning, we have a plan of how to do it. We have like maps for utilities underground and where they should go and how they should change. But part of what we're doing is creating these standards. Every building's going to have a standard of how much energy it should use. And so when we plan a renovation, or if we plan, different departments moving to different buildings, how do we increase the efficiency of that building? How do we do it? How do our contractors and our architects do it? It's becoming part of how we operate in the operations department at Tufts. Same thing with maintenance planning. This is really key. It used to be, if something broke, you just replaced the exact same thing, but the newer model. And now the goal is, if you have something that relies on steam and it breaks, we want to see if we can replace it with something that relies on hot water. And how can we connect that piece of equipment to hot water somewhere on the campus, instead of just saying, go buy the same thing, but the newer version. It takes a little bit more time, right? Because you know what the old thing was. You can replace that. You can replace your window air conditioning unit because you just go to Home Depot and buy a new one. But it's better for us if we change that building either to have chilled water sent from the central energy plant, or you have a heat pump in that room. Heat pump does heating and air conditioning, not just heating. But that takes more forethought, that takes more changes in the infrastructure. So we can't just sort of replace what we had, but we have to figure out how to replace with what we want to be, even if that particular building isn't ready to be what we want it to be. That's one of our challenges, is how do we sort of leapfrog from where we are to where we want to be. And then also we are working on the Grafton and Boston campuses. Those plans are not as far along as this plan, as the Medford plan. And this actually, I don't know if you guys know, this is Gancher, and we have solar that we put on there, I think even a year ago. And this is the new Cummings building, and that's going to have solar panels as well. And the side of Cousins is also going to have solar. So we're putting solar wherever we can on any roof that we could put it on. Just one other quick thing. One of the things that we have, one of the tools that we have is, and this is not a great slide, I apologize for that, but all of these little dots are our buildings, and the size of them is the amount of energy use that building consumes. So this is our central energy plant, the big one in the middle, which consumes the most, clearly, because it's making the most energy. But part of what we're able to track is how much energy it's using compared to all the other buildings. And if you click on a little dot in this dashboard, you'll see lots of pieces of information about that building. And so we're trying to start to see at a global scale, what are the buildings that are the worst emitters, right? And what are they near? How can we change that building, or how can we change the neighborhood where that building, sits, so that it either A, becomes more efficient and emits less carbon, or B, connects itself to an engine that's more efficient and gets its heating and cooling from the engine. So I think that's it. And so I'm happy to take questions, or however you want to go from here, Tina.
Sure. Shoshana's going to read a couple questions from the chat.
All right, I'm going to go back a slide because it's nicer than just the thank you.
There's actually, I'll start with the question about the dashboard, which actually reminds me, we haven't done a lot of outreach about the dashboard yet. And I don't know if anyone on here is one of the creators of the dashboard, but hopefully it's ready to be publicly shown to folks soon. But so we got a question that was, how often is the dashboard updated, and is it live data?
Yes, yes, and yes. So I am not the creator or the owner of the dashboard, so I'll tell you what I know, but if anybody else on the webinar knows more than me, please speak up. Basically, the dashboard is constantly being fed information from our utility bills, and it calculates the square footage of the building, the energy consumption, and that gets the energy use intensity. So it's sort of constantly being updated. I mean, the size of the circle wouldn't change on a monthly basis because, each month you don't use that much. But over time, like we did a renovation to Miller and Houston. If we had this dashboard 4 years ago, the size of the dot for Miller and Houston would be smaller now than it was 4 years ago. So yes, it's live. Yes, it's constantly updated, but you don't see the change instantly.
Okay, that makes sense. We had a very a question that must be from an engineer earlier when you were talking about heat pumps.
Yeah.
They asked if you have to heat wet buildings with heat pumps, do you need lots of downstream hydronic modifications to use a lower hot water temperature?
So I think the answer is no, because you're not really messing with any hydronic pressure with the heat pump. We could get into this more if you want, but the heat pump doesn't really affect the pressure that you need for the water to move around the building. Does that help?
I guess, yeah, the word hydronic is a bit beyond me, but I'll let that person answer in the chat. They can always email you too.
Yeah, they can email me if they want to talk more about it.
And we just got another question. If does Medford Somerville have a requirement to put solar panels on buildings of a certain size?
No, so Medford is what's called a green community, which means they've committed for their own city to have certain goals, and they can get funding to help achieve sustainability and carbon neutrality. Part of being a green community is that you're easier on permitting solar panels on a roof or solar panels over a parking lot. So the permitting process for putting solar panels on is a lot easier because Medford has committed to being a green community. There's no requirement because you can't require, well, you could start to require. I mean, some communities are starting to say you can't build any new houses with fossil fuels. That's been challenged in court, so it's a little bit kind of iffy. So no, they don't have a requirement, but they do agree to make it easier to get a permit to put panels on the roof. They're also very supportive. I mean, Medford and Somerville are extremely supportive of all of our carbon neutral and sustainable goals. They're of like minds like we are.
Yeah, we could almost, I mean, unless we discuss it more today, we have thought about having another webinar just about the solar at Tufts, because that's like kind of a whole, thing as well.
Right.
And then another question, and Tina might have thoughts on this too, is are there checkpoints for progress? So like that we would have to, by a certain year, we need to have done X. But I guess there's kind of, it's more so about the decarbonization plan probably.
Right. So in Boston, there actually are requirements. You have to lower your carbon emission by a certain percentage over certain years. If you don't, you pay a fine. But in Medford and Somerville, there isn't that. And we internally have not created sort of, let's meet this percentage reduction by this year. I guess I would feel like we are, moving as fast as we humanly can. And so I don't think we need an external deadline in terms of like X percentage by X year. I think it's good for us to monitor and manage how much we're reducing. But I guess for me, I don't need someone to say, hurry up, because I'm trying to hurry up. So, but I don't know, Tina, if you want to talk more about that.
Well, one of the things I was going to mention a little later is that we are starting next week from tomorrow, a new sustainability council that's going to look at goals for the university. So it's going to look at principles, values, and goals for the university, very high level. It is made up, it's small for decision-making purposes, but it's made up of faculty and some students, and then just a couple administrators to help run it. So it's possible that they will have some intermediary goals come out of that. Shoshana, there's a question for you. How is the greenhouse gas reduction graph derived? It's from Carly.
Yes. Well, so luckily, I also, I do the greenhouse gas graph that shows all scope 1, scope 2, and scope 3. So scope 1 is the energy that the stuff that we burn on campus. So that would be like natural gas burning at the CEP. And so I get that data from the energy bills, just as the folks that create this dashboard in facilities engineering department. So we're using the same data. And then scope 2 is the energy that we purchase. So that's electricity from the grid. And we also purchase steam to heat the Boston campus. That's also from utility bills. We use much more of our greenhouse gas emissions come from natural gas than electricity, which Ruthie mentioned. And part of that is because we basically transitioned Medford campus when we started with the central energy plant. We used to use a lot of electricity from the grid. And then we instead took natural gas and created electricity for our buildings. So all of a sudden, that greenhouse gas that was coming from electricity is now coming from natural gas for the Medford campus. And then there's like there's scope 3, which includes air travel on university business, study abroad air travel, employee and student commuting. Those are the big parts of scope 3 that make up greenhouse gases. So we could have another webinar on that. We basically have to get data. Some of it's a bit estimated, but from various parts of the university. It's a little less reliable than the energy greenhouse gas emissions because we have utility bills.
One thing I'll comment on what you said, Shoshana, which is someone might say, well, then why did we make the central energy plant if we were getting electricity from the grid? And what I want folks to remember is the central energy plant is really a tri-generation plant. So every single therm of gas that we get, we kind of use it 3 times. So although we are using gas, we're using it efficiently. And at the same time, we do have electricity. Some parts of the campus are connected to the grid. And again, the grid is getting greener. So there's no one answer to how we're going to get to be carbon neutral. It's going to be multiple ways, depending on which campus, which building, how close they are to the central energy plant, how far away they are from that. The alternative fuel industry, there's now Eversource is actually trying to figure out how to put alternative fuel in their gas pipes, right? Because they clearly have gas pipes from their production plants to our campuses or to everybody's houses. And could they change to use alternative, which would be amazing. That would be like the great answer. I'm not sure they're going to do that. But they're talking about a pilot project because, again, the challenge is how do you take whatever is alternative and get it to the buildings? Right? How do you put it in the pipes underground? Because those pipes are already used for the old way, for the natural gas way. So.
Yeah, I would just add to that. I'm looking at Tufts energy over time graphs and our greenhouse gases over time. And you kind of mentioned this earlier, but our energy has pretty much stayed pretty much the same, the amount of energy we're consuming each year recently, but our greenhouse gases have slightly decreased. I guess in recent years, yeah, they've slightly decreased more recently in 2020. So as Ruth mentioned, the more you decrease that energy consumption, then we're definitely going to decrease the greenhouse gases as well.
Right. And also remember, we've added a couple 100,000 square feet of building over that time. So the fact that we sort of remained the same or went down actually is sort of a success story. We didn't go up.
So you're improving your energy use intensity, your EUI of campus.
Right.
Are there any other questions? We're getting some appreciation in the chat.
We could take that too.
All right. So I just want to thank Ruthie in particular for speaking today. Thank you. And to thank all of you for participating today. Really enjoyed having a conversation with you all. You can look forward to next month. We are hoping to have Tufts Chief Investment Officer Craig Smith join us to discuss the endowment, how the endowment works, and also the divestment announcement that happened earlier this year. So that'll be great. We also want to have webinars on Tufts greenhouse gas emissions, where we can go more deeply into that, Tufts dining efforts to reduce their carbon emissions, and lots more. So sign up for our newsletter to get announcements about that. And also I encourage you all to peruse our website at sustainability.tufts.edu, which has a lot of information about what's been done in the past, what's currently going on, et cetera, et cetera. Thank you all.
Thanks. Bye.